So what we've tried to do in this third iteration is to add a little bit more sophistication to the pipetting action. And the first part of that is actually to put an input field onto the canvas on that world space pipette canvas. Now, this input field is going to be where we add the volume that we want the pipette to either expel or suck up. Uh, I must admit that I'm not totally happy at the moment with how you set the scale and the size um, of, of this input field and how you set the canvas. You'll notice that what I've done differently to the first lesson is that I've actually made the scale of the canvas really small, but the width um, much bigger. So basically, instead of having this as 1 and this is 1, I've made this 0.01 and there's 100. And I did this because I was recommended to do that by a YouTube video, but I'm not totally convinced of their explanation yet. Anyway, what I can say is that when I did that, it did mean that when I put the input field on and I scaled that really small and I made the text really big, then you end up with a result that looks quite good. And I can make an input to that. I can call or make a reference to that input field from the pipette action script, and that will then mean that I've got some control over the volumes that are being administered. The other major change here is that I've just codified the names of things a bit better. Instead of calling this plastic, I made an empty game object called model, and I've made a separate barrel portion and a separate tip portion, just so that we've got something that looks a little bit more like a pipette. The other major change has been with the tube prefab. Again, I've replaced the word plastic with the word model because later on that shell, that plastic shell, will be a lot nicer looking. It'll look like an Eppendorf tube or something like that. Similarly with the liquid, I've replaced the word cylinder with lick cylinder just to make it clear that it is part of the liquid. And I've added another component, another cylinder, but this time without a mesh renderer. And this is just acting as a reference for where the meniscus is. And the reason for that is that I want the pipette tip to always go to the meniscus. When the pipette goes to a tube, it feels natural for it to go to just above the meniscus, because that's where you'd put it if you were doing real pipetting operations. I changed the name of the button on the canvas that directs the pipette tip, and this was quite interesting actually, because I also changed the name of the game object, the pipette, and they ended up having the same name, which actually caused a really big complication in the script, because if you remember that what the script does, it actually goes to find the thing that's called pipette, and of course it was finding that button instead of the main pipette. So that's a really good note of caution there to make sure that you name things precisely and unambiguously. On this panel, I've put a text mesh pro field, and at the moment that's going to hold the volume, but it can actually hold quite a lot of information. I mean, we can start thinking about other bits of information that we might want to hold about this tube at any given time. It could be temperature, could be the concentration of things. So quite a lot of things might eventually go into an information panel about the tube. But this is a good start. And again, remember this is a world space canvas. I can't set the event camera for this because it's a prefab, whereas I could set the event camera for the canvas in the pipette. That may change, of course, if I start making it so that the pipette is instantiated, but from a prefab. But just going back to this tube, again, not quite sure what to do about the size of this. This is the, the same as what it was before. It's a scale of 1, which makes the canvas really small, and then that makes the text mesh pro field, the rect transform on that very small, and the font absolutely tiny. So how we get sort of realism into this is is something I'm still learning, but it works, and it works quite well. Um, so as we saw in the sort of summary video, we can type numbers in here like 345, and then when we direct the pipette to the tube, we can dispense 345 and another 345, and we can take away, say, 126, and it will do that. It will calculate what's left. So that's good. Um, that all works very nicely, and you'll notice the pipette tip always goes to the meniscus. One thing that we might want to do actually is when we add, it might be better if this panel with the arrows and the amount stays in the same spot, because it is actually a bit disconcerting the way it moves up and down, because it means you have to change the position of your mouse. But that's something we can do next time. So just to have a look at the scripts then, this is the pipette. Well, we'll go to the pipette guide one. It's the simplest. We're finding that the object called pipette, and again, make sure there's only one thing called pipette in the scene, and we're making it so that it knows what tube it's over, what tube it's going to interact with, and this time there's no droplet to make. So this time that relationship between the pipette and the tube doesn't have the intermediary. And then we send the tip to the meniscus, and this is taken care of in the pipette action script. What it does is it changes the position of the pipette. Remember, that's what this script is on, so that's what will be affected by the transform position. And we send it to wherever the active tube is, or specifically where the meniscus is in the active tube. So in a minute we'll have a look to see how we define the meniscus position, and that is a little, as we explained earlier, it's just a little cylinder that doesn't have a renderer on it. It's just there to act as a marker. But we don't put it to exactly there, we actually put it to just above. And I don't like this. This reeks of magic numbers. As all good programmers know, you should never have these arcane, arbitrary numbers like this floating around that you don't really know where they came from. You don't know why they're the magnitude of what they are. So we will codify that a bit further down the track so that we take into account the size of the tip and make sure that the bottom of the tip is always going to be just above the meniscus. So that meniscus position, the meniscus, remember, is a cylinder which is going to lie on top of the liquid. So we have a game object called meniscus, and it's defined here with these two lines. The meniscus height is going to be whatever the Y position of the liquid cylinder is, which you remember moves up as we add things in, plus the height of the cylinder. So the that's in the center, that that, transform position Y there, and the cylinder height takes the height up a little bit further, so it is actually the meniscus. That becomes the top of the liquid. The meniscus game object can then be moved to that position. So the meniscus game object, which is where the pipette is going to be teleported, is defined by the top of the liquid. Now, when we press the arrows on the pipette, we're going to be either sucking up or dispensing. And there are two things we need to check before we do either of those actions. First of all, we need to check that there is an active tube, because you can imagine that if we were to press these buttons without it being over an active tube, it would throw an error, because if there's no active tube, it will say game object, reference to game object not found. So we must ensure that we've got an active tube referred to, it's not null. And then the other thing we need to check is that there's a parsable number in the input field. Now, it would be better in the long run to allow the user to type in something like 160 UL or 160 space UL or something like that, and parse out the number part. But for the time being, I'm just saying, unless you can find a float or something that can be turned into a float in there, don't go to the next step. Now these two things are checked regardless of whether we're sucking up or dispensing. So I think a more efficient way of doing this in future would be to make it so that when you press the buttons, they happen, and then the thing that distinguishes the sucking up from the dispensing is done within that nest. But this is fine at the moment. In other words, what I'm saying is that these two functions are exactly the same. They just differ with respect to this bit, and so that's a bit of inefficiency in coding, and I can make that a little bit better. But now, instead of calling those functions in liquid in tube that we used to have that sent the value of 100 to here, we're now sending a customized value to the adjust volume function. Now, after the adjust volume function is run, not only does it change the meniscus height, but it also updates info. And all that's doing is changing the little bit of TextMesh Pro that is on the tube canvas, and it's just updating the volume. So we've got a reference to that TextMesh Pro up here. So those are the major changes. The pipette guide now sends things to the meniscus. The pipette actions help with that sending to the meniscus, and the arrows are now linked to these functions that allow us to put in a customized amount, and the liquid in tube. Mainly, the main difference here is that we're keeping track of where the top of the liquid is and sending the pipette tip there. So all that looks pretty good. I think what we should start to do next is to build a proper model for the tubes, and so that it look a little bit more realistic. Maybe have a better way of teleporting the pipette into the tube, and maybe making it so that we see some liquid actually appearing in the pipette tip when we do the pipetting actions.